if cos theta plus cot of pi by 4 plus theta is 2, then the general value of theta is, the options are 2n pi plus or minus pi by 6, 2n pi plus or minus pi by 3, n pi plus or minus pi by 3, or n pi plus or minus pi by 6. So first step is we convert everything into sine and cos. So cot theta is cos theta upon sine theta plus cos of pi by 4 plus theta upon sine pi by 4 plus theta. This is equal to 2. Now we cross multiply the terms, we get cos theta sine pi by 4 plus theta plus cos of pi by 4 plus theta into sine theta is equal to, we bring the denominator to the RHS, so that is 2 into sine theta sine of pi by 4 plus theta. Now this is in the form of cos A sin A cos B plus cos A sin B. This is the formula for sine of A plus B, that is sine of pi by 4 plus theta, that is equal to 2 sine theta sine pi by 4 plus theta. So this is equal to sine of pi by 4 plus 2 theta. Now we can write this, this is in the form of 2 sine A sine B. So we can write this as cos of theta minus pi by 4 plus theta minus cos of theta plus pi by 4 plus theta. This gives sine of pi by 4 plus 2 theta is equal to cos of minus pi by 4 minus cos of pi by 4 plus 2 theta. So we bring this term to LHS, we get sine of pi by 4 plus 2 theta plus cos of pi by 4 plus 2 theta. Now cos of minus theta is cos theta, so cos of minus pi by 4 is cos pi by 4, which is 1 by root 2. Now these terms we expand it and we get 1 by root 2 cos 2 theta. 1 by root 2 is sin pi by 4 and cos pi by 4. So cos 2 theta plus 1 by root 2 sin 2 theta. This is for the first term, that is sin of pi by 4 plus theta 2 theta plus 1 by root 2 cos 2 theta minus 1 by root 2 sin 2 theta. This is equal to 1 by root 2. So we are left with, this term gets cancelled and we are left with 2 times 2 by root 2 cos 2 theta is equal to 1 by root 2. Root 2 gets cancelled, so this is cos 2 theta is half. Therefore 2 theta is cos inverse of half, which is pi by 3. So in general we can write 2 theta is 2n pi plus or minus pi by 3. Now we divide throughout by 2, so we get theta is n pi plus or minus pi by 6, which is option D. If 4 sin square theta plus 2 into root 3 plus 1 cos theta is 4 plus root 3, then the general value of theta is option A 2n pi plus or minus pi by 3, B 2n pi plus or minus pi by 3 plus pi by 3, C n pi plus or minus pi by 3, D n pi minus pi by 3. So first we convert this term into cos. So this is 1 minus cos square theta plus 2 into root 3 plus 1 cos theta equals 4 plus root 3. So we get a quadratic equation of cos theta. So we expand this, we get 4 minus 4 cos square theta plus 2 into root 3 plus 1 cos theta is equal to 4 plus root 3, that is 4 cos square theta minus 2 into root 3 plus 1 cos theta plus root 3, this term gets cancelled, is equal to 0. So this is a quadratic equation for cos theta. So cos theta is given by minus b plus or minus root of b square minus 4ac upon 2a. So we can write this as 2 into 3 plus 1 root of 2 into root of 3 plus 1 plus or minus root of 4 times root 3 plus 1 the whole square minus 4 into root 3 divided by 2 times a, that is 4. So we get cos theta is either root 3 up to root 3 by 2 or 1 by 2, that is theta equals cos inverse of root 3 by 2 or cos inverse of half, that is theta is equal to, in general form, that is 2n pi plus or minus pi by 6 or theta is equal to 2n pi plus or minus pi by 3. So among these only this is in the option, which is option A. So the answer for general value of theta is 2n pi plus or minus pi by 3. In triangle ABC, a minus b the whole square into cos square c by 2 plus a plus b the whole square into sin square c by 2 is equal to option A square, option B square, C square and D bc. So we rewrite the equation a minus b the whole square cos square c by 2 plus a plus b the whole square sin square c by 2. Now a minus b the whole square can be written as a square plus b square minus 2ab into cos square c by 2 plus this is a square plus b square plus 2ab into sin square c by 2. Further expand in this and taking cos square c by 2 and sin square c by 2, expanding this term, we get a square plus a square cos square c by 2 plus b square cos square c by 2 minus 2ab cos square c by 2 plus a square sin square c by 2 plus b square sin square c by 2 plus 2ab sin square c by 2. This is equal to 0. This can be written as a square plus b square cos square c by 2 plus sin square c by 2 plus 2ab sin square c by 2 minus cos square c by 2. So this term is 1. So we have a square plus b square plus 2ab into sin square c by 2 minus cos square c by 2. So sin square theta minus cos square theta is nothing but cos of 2 theta. So in this case it is a square plus b square plus minus there's a minus sign, cos square theta minus sin square theta is cos of cos of 2 theta. So we have minus 2ab into cos square c by 2 minus sin square c by 2, that is a square plus b square minus 2ab into this term is cos c, it is cos c. Now by using cosine rule we can simplify it further. So we get a square plus b square minus a square plus b square minus c square. This is obtained by using cosine rule for cos c, and this term gets cancelled out. So a square gets cancelled in this step. So it is, so this term is in bracket. B square gets cancelled. So we are left with minus of minus c square. That is equal to c square, which is option C, c square. If cos of A plus cos of B is 4 times sin square c by 2, then sides of the triangle ABC are in A AP, B GP, C HP and D AG. So first we rewrite the equation. Cos of A plus cos of B equals 4 sin square c by 2. This can be written as 2 cos A plus B by 2 into cos A minus B by 2, and this is 4 sin square c by 2. Now A plus B can be written as cos of pi minus c, because sum of all angles of a triangle is 180 degree, that is pi radians. So A plus B plus C is pi, therefore A plus B is pi minus C, that is equal to A minus B by 2, and this is 4 sin square c by 2. This is 2 cos of pi by 2 minus c by 2, so we can rewrite this as 2 sin c by 2 into cos A minus B by 2, that is equal to 4 sin square c by 2. Sin c by 2 gets cancelled, so we are left with 2 cos A minus B by 2 equals 4 sin c by 2. So we multiply sin A plus B by 2 on both sides, so we get 2 cos A minus B by 2 sin A plus B by 2 is equal to 4 sin c by 2 into sin A plus B by 2. So this term is again pi by 2 minus c by 2, so this term can be written as cos of c by 2. So next step is, now this term can be written as sin of A plus sin of B by using the formula 2 cos A, theta sin theta. Sin of A plus sin of B is equal to 2 into 2 sin c by 2, and this is cos c by 2, and we split the number 4 into 2 into 2. So this is sin of A plus sin of B is 2 sin c by 2 into cos c by 2 is sin c, so 2 sin c. Therefore we can say A plus B is equal to 2c. So therefore A, C and B are in AP, since it satisfies the condition for arithmetic progression. So the answer is A, AP. In triangle ABC, if sin square A by 2, sin square B by 2 and sin square C by 2 is in HP, then ABC will be in option A AP, option B GP, option C HP and option D AG. So it is given that sin square A by 2, sin square B by 2 and sin square C by 2 are in AP. So we can say that they are in HP. So their reciprocals are in AP. So we can say 1 upon sin square C by 2 minus 1 upon sin square B by 2 is equal to 1 upon sin square B by 2 minus 1 upon sin square A by 2. This means the difference between the terms are the same. Now by the property of triangle we can write this as 1 upon s minus a into s minus b upon ab minus 1 upon s minus a into s minus c upon ac, that is equal to 1 upon s minus a into s minus c upon ac minus 1 upon s minus b into s minus c upon bc, that is ab upon s minus a into s minus b minus ac upon s minus a into s minus c is equal to ac upon s minus a s minus c minus bc upon s minus b into s minus c. Now in LHS we take a upon s minus a common, so we are left with b into s minus c minus c into s minus b upon s minus b into s minus c, that is equal to RHS. That is in RHS we take c upon s minus c common, so we are left with a into s minus b minus b into s minus a upon s minus a into s minus b. So now the denominators are equal, so they get cancelled out, we are left with, and now we expand it simultaneously, so we get abs minus abc minus acs plus abc is equal to RHS, that is acs minus abc minus bcs plus abc. Simplifying it further, we get ab minus ac is ac equals ac minus bc, that is ab plus bc is equal to 2ac. So dividing throughout by ac, we get ab upon ac plus bc upon ac is equal to 2. So this gives b by c plus b by a equals 2. Now again dividing throughout by b, we get 1 by c plus 1 by a equals 2 by b, which is the condition for harmonic progression. So the sides a, b and c will be in harmonic progression, that is option C. We are supposed to find the greatest and the least value of sine inverse of x the whole cube plus cos inverse of x the whole cube. The options are minus pi by 2 comma pi by 2, minus pi cube by 8 comma pi cube by 8, 7 pi cube by 8, pi cube by 32 and 7 pi by 6, pi by 6. So first we rewrite the expression sine inverse of x cube plus cos inverse of x cube. Now this can be written as, this is in the form of a cube plus b cube, so we can rewrite this as sine inverse x plus cos inverse x the whole cube minus 3 times sine inverse x into cos inverse x into sine inverse x plus cos inverse x. Now sine inverse x plus cos inverse x is pi by 2, so this is pi by 2 cube minus 3 sine inverse x cos inverse x into pi by 2, that is pi cube by 8 is 3 pi by 2 sine inverse of, now cos inverse of x is pi by 2 minus sine inverse of x, so this can be written as pi by 2 minus sine inverse of x, that is pi cube by 8 minus 3 pi by 2. We take this term inside the bracket, so we get pi by 2 sine inverse of x minus sine inverse of x the whole square. Taking minus 1 common, we get pi cube by 8 plus 3 pi by 2 sine inverse x the whole square minus pi by 2 sine inverse of x. Now we add and subtract pi cube by 16. So here it is pi cube by 8 plus 3 pi by 2 sine inverse of x square minus this can be written as 2 into pi by 4 sine inverse x, and now we add and subtract pi by 4 the whole square, that is pi square by 16. So this is plus pi by 4 the whole square minus pi by 4 the whole square. We take this term outside the bracket, so we get pi cube by 8 minus 3 pi upon 2 into pi square by 16 is 3 by 32 pi cube. Now this is in the form of a square minus 2ab plus b square. So we can write this as a minus b the whole square, that is sine inverse of x minus pi by 4 the whole square. Plus into 3 pi by 2. So this is equal to, we add this pi cube into 4 by 32 minus 3 by 32 is sine inverse x minus pi by 4 the whole square, that is pi cube by 32 plus 3 pi by 2 sine inverse of x minus pi by 4 the whole square. Now for the least value, the minimum value of this expression is 0 because sine inverse of 0 will be 0. So the least value will be pi cube by 32, and the maximum value of sine inverse of x is pi by 2. So for that condition, sine inverse of x minus pi by 4 will be less than equal to 3 pi by 4, because when the angle is 3 pi by 4, we get sine inverse of the angle turns out to be 90 degree. So for maximum condition, sine inverse of x minus pi by 4 is equal to 3 pi by 4. So substituting this term in this expression, we get pi cube by 32 plus 3 pi by 2 into 3 pi by 4 the whole square, that is equal to pi cube by 32 plus 9 pi square into 3 pi divided by 16 into 2, that is equal to 7 pi cube by 8. This is the maximum value. So the maximum value is 7 pi cube by 8 and minimum value is pi cube by 32, which is option C. We need to simplify this polynomial, this expression, that is tan inverse of c1 x minus y upon c1 y plus x plus tan inverse of c2 minus c1 upon 1 plus c2 c1 plus tan inverse of c3 minus c2 upon 1 plus c3 c2, and so on and so forth until tan inverse of 1 by cn. The options are tan inverse of y by x, tan inverse of yx, tan inverse of x by y, and tan inverse of x minus y. So first we take c into y common for this expression. So this is, we get this as x by y minus 1 by c1 upon 1 plus x by yc1. We took yc1 common in this term plus tan inverse of, here we take c1 c2 common, so we get 1 by c1 minus 1 by c2 upon 1 plus 1 by c1 c2. Similarly, we take c2 c3 common in this term, so we get tan inverse of 1 by c2 minus 1 by c3 upon 1 plus 1 by c2 c3. so on and so forth until tan inverse of 1 by Cn. Now this can be written as tan inverse of x by y minus tan inverse of 1 by C1. This plus this can be written as tan inverse of 1 by C1 minus tan inverse of 1 by C2. Similarly, this can be written as tan inverse of 1 by C2 minus tan inverse of 1 by C3. So on and so forth till we get tan inverse of 1 by Cn. Now this term gets cancelled, this gets cancelled, again this that gets cancelled, and we are left with only tan inverse of x by y, which is option C. If 3 sin inverse of 2x upon 1 plus x square minus 4 cos inverse of 1 minus x square upon 1 plus x square plus 2 tan inverse of 2x upon 1 minus x square is equal to pi by 3, then x equals what? Options are root 3, 1 by root 3, 1 and 2 by root 3. First we take, let x equals tan theta. So we substitute this in the expression, we get 3 sin inverse of 2 tan theta upon 1 plus tan square theta minus 4 cos inverse of 1 minus tan square theta upon 1 plus tan square theta plus 2 tan inverse of 2 tan theta upon 1 minus tan square theta, which is equal to pi by 3. Now 2 tan theta upon 1 plus tan square theta is sin 2 theta. So this is sin inverse of sin 2 theta minus 4 cos inverse of, this is the formula for cos 2 theta. So this is cos inverse of cos 2 theta. Similarly, this is 2 tan inverse of, this is the formula for tan 2 theta. So this is tan 2 theta. The inverse cancel each other. So we are left with 3 into 2 theta minus 4 into 2 theta plus 2 into 2 theta is equal to pi by 3. That is 6 theta minus 8 theta plus 4 theta is equal to pi by 3. So therefore we get theta is equal to pi by 6. Therefore now x is tan theta, therefore theta is tan inverse of x. So therefore tan inverse of x is pi by 6. That is x is tan pi by 6, which is equal to 1 by root 3. So the answer is B, 1 by root 3. The equation 3 sin square x plus 10 cos x minus 6 equals 0 is satisfied if x equals n pi plus or minus cos inverse of 1 by x, x equals 2n pi plus or minus cos inverse of 1 by 3, x equals n pi plus or minus cos inverse 1 by x, or x equals 2n pi plus or minus cos inverse 1 by 6. So first we find the roots of this equation. So sin square x can be written as 1 by 1 minus cos square x. So this is 3 into 1 minus cos square x plus 10 cos x minus 6 equals 0. Simplifying it, we get 3 cos square x minus 10 cos x plus 3 is equal to 0. We got a quadratic equation of cos x. So this can be written as 3 cos square x minus 9 cos x minus cos x plus 3 equals 0. That is, we take 3 cos x common. So this is cos x, 3 cos x, cos x minus 3 minus 1 cos x minus 3, that is equal to 0. So the cos x minus 3 into 3 cos x minus 1 is equal to 0. So either cos x minus 3 equals 0 or 3 cos x minus 1 is equal to 0. that is cos x is equal to 3 or cos x equals 1 by 3. Now cos x cannot be greater than 1, so this is not a valid equation. So cos x must be equal to 1 by 3. So let this be cos alpha. So x is equal to 2n pi plus or minus alpha. So alpha in this case is cos inverse of 1 by 3. So therefore x is equal to 2n pi, which is the general equation for cos inverse x, 2n pi plus or minus cos inverse 1 by 3, which is option B, 2n pi plus or minus cos inverse 1 by 3. If if 2 sin square x plus sin square 2x is equal to 2 and x lies between minus pi and plus pi, then what is the value of x? The options are plus or minus pi by 6, plus or minus pi by 4, 3 pi by 2, or none of these. So firstly we will convert the sine terms into cosine. So sin square can be written as 1 minus cos square x. So this is 1 minus cos square, or we can write this in the form of cos 2x. So this is 1 minus cos 2x plus this can be written as 1 minus cos square 2x is equal to 2. Now cos 2x, 2 gets cancelled, we are left with cos 2x into cos 2x plus 1 is equal to 0. That is cos 2x is equal to 0, or 1 plus cos 2x is equal to 0. That is 2x equals cos inverse 0, or 2x equals cos inverse of minus 1. So for cos theta equals 0, theta will be defined as 2n plus 1 into pi by 2 for general value of theta, and for cos theta is equal to minus 1, theta will be defined by 2n plus 1 into pi. So we have 2x equals 2n plus 1 pi by 2, or 2x is equal to 2n plus 1 into pi. That is x is equal to 2n plus 1 pi by 4, or x is equal to 2n plus 1 pi by 2. Now we put n is equal to minus 2 comma minus 1 comma 0 comma 1 comma 2. We get various values of x, which are x equals minus 3 pi by 4 comma minus pi by 4 comma pi by 4 comma 3 pi by 4 up to infinity, or x is equal to minus 3 pi by 2 comma minus pi by 2 comma pi by 2 comma 3 pi by 2 up to infinity. So now x lies between minus pi to plus pi. So within the option only this is the value of x which lies between minus pi to plus pi. So x must be plus or minus pi by 4, which is this term. So the answer is B, plus or minus pi by 4. We have to find the solution of the equation cos square x minus 2 cos x is equal to 4 sin x minus sin 2x. The condition is given for x that x lies between 0 and pi. So the options are pi minus cot inverse of half, pi minus tan inverse of 2, pi plus tan inverse of minus half, or none of these. So first we simplify this equation. We get cos square x minus 2 cos x equals 4 sin x minus sin 2x. Sin 2x can be written as 2 sin x cos x. So this is cos square x minus 2 cos x equals 4 sin x minus 2 sin x cos x. We take 2 sin x common here and we take cos x common here. So we get cos x minus 2 is equal to 2 sin x 2 minus cos x. We shift this term to LHS. We get cos x to cos x minus 2 minus 2 sin x 2 minus cos x is equal to 0. We take minus 1 common here. So we get cos x minus 2 plus 2 sin x cos x minus 2 is equal to 0. That is cos x minus 2 into cos x plus 2 sin x is equal to 0. So therefore either cos x minus 2 is 0 or cos x plus 2 sin x is 0. So cos x is equal to 2 or cos x plus 2 sin x is equal to 2. Now this case is not possible because cos x cannot exceed 1. So this value is this assumption is true, that is cos x plus 2 sin x is equal to 0. So now cos x, we simplify this, we get cos x equals minus 2 sin x. That is tan x, we shift this term to RHS and this to LHS. So tan x is equal to minus half. Let this be tan alpha. So general value of x for tan alpha is given by n pi plus alpha. So alpha is tan inverse of minus half. So we have x is equal to n pi plus tan inverse of minus half. Now x lies between 0 and pi. So we can say x equals pi plus tan inverse of minus half, which is option C, pi plus tan inverse of minus half. The smallest positive value of x and y satisfying x minus y equals pi by 4 and cot x plus cot y is equal to 2 are, options are x equals pi by 6, y equals 5 pi by 2, x equals 5 pi by 12, y equals pi by 6, x equals pi by 3, y equals 10 pi by 12, or none of these. So we have two conditions, x minus y equals pi by 4. That is x is equal to y plus pi by 4. Let this be equation 1. Also cot x plus cot y is equal to 2. Let this be equation 2. So substituting equation 1 in 2, we get cot of y plus pi by 4 plus cot y is equal to 2. Now formula for cot y plus a plus b is that is cot of y plus pi by 4 is, this can be simplified into cot y minus 1 upon cot y plus 1 plus cot y is equal to 2. So multiplying throughout by cot y plus 1, we get cot y minus 1 plus cot y into cot y plus 1 is equal to 2 cot y plus 1, 2 times. That is cot y minus 1 plus cot square y plus cot y is equal to 2 cot y plus 2. So this term gets cancelled and this goes to RHS. So we are left with cot square y is equal to 2 plus 1 is equal to 3. So cot is tan inverse of tan. So tan square y is 1 by 3. That is tan y is equal to that is tan square y is tan square pi by 6. So therefore we can say that y is equal to pi by 6. So therefore x is y plus pi by 4, which is equal to pi by 4, pi by 6 plus pi by 4, which is 5 pi by 12. So the answer is x equals 5 pi by 12 and y equals pi by 6, which is option B. If cos 2 theta is root 2 plus 1 into cos theta minus 1 by root 2, then the value of theta is, options are 2n pi plus pi by 4, 2n pi plus or minus pi by 4, 2n pi minus pi by 4, or none of these. So cos 2 theta is root 2 plus 1 cos theta minus 1 by root 2. Now we take 1 by root 2 common here in LHS, and cos 2 theta can be written as 2 cos square theta minus 1. So this is taking 1 by root 2 common, so into root 2 cos theta minus 1. We take this term to the LHS, we get 2 cos square theta minus 1 minus root 2 plus 1 upon root 2 into root 2 cos theta minus 1. Now here we take root 2 cos theta minus 1 common. We are left with root 2 cos theta plus 1. Since this is in the form of a square plus a square minus b square, so this can be written as root 2 cos theta minus 1 and root 2 cos theta plus 1. So this minus root 2 plus 1 upon root 2. This is equal to 0. So either root 2 cos theta minus 1 is equal to 0, or root 2 cos theta plus 1 minus root 2 plus 1 by root 2 is equal to 0. Therefore cos theta is either 1 by root 2 or cos theta is root 2 plus 1 by root 2 minus 1. That is root 2 cos theta is root 2 plus 1 minus root 2 divided by root 2. So cos theta is bringing this root 2 here, so we get root 2 gets cancelled, so this is 1 by 2. So cos theta is either 1 by root 2 or 1 by 2. So cos theta is either pi by 4 or cos theta is equal to cos of pi by 3. So therefore in general we can write this as theta is equal to 2n pi plus or minus pi by 4, or theta is equal to 2n pi plus or minus pi by 3. So since the option contains the angle pi by 4, we consider this equation. So theta is 2n pi plus or minus pi by 4, which is option B. The number of values of theta in the interval minus pi by 2 to pi by 2 such that theta is not equal to n pi by 5 for 0 plus or minus 1 plus or minus 2, and the conditions are tan theta is equal to cot phi theta, and condition 2 is sin 2 theta is cos 4 theta. So the values, number of values of theta may be 4, 5, 7 or 3. First we consider case 1, that is tan theta is equal to cot of phi theta. So that is tan theta minus cot phi theta is equal to 0. So converting everything into sin and cos, we get sin theta upon cos theta minus cos theta upon cos phi theta upon sin theta is equal to 0. Cross multiplying it, we get sin square theta sin phi theta into sin theta minus cos phi theta into cos theta is equal to 0. That is cos phi theta into cos theta minus sin phi theta into sin theta is equal to 0. Now this is the formula for cos of a plus b. So we can write this as cos of phi theta plus theta, which is equal to 0. Therefore cos of 6 theta is equal to 0. So general value for 6 theta can be written as 6 theta is equal to 2n plus 1 pi by 2. So the possible values are 6 theta is equal to plus or minus pi by 2 plus or minus 3 pi by 2 plus 5 pi by 2. Therefore theta is plus or minus pi by 12 plus or minus pi by 4 and plus pi by 12. Equation case 1. Now case 2 is cos 4 theta is equal to sin 2 theta. So sin 2 theta is equal to cos 4 theta can be written as 1 minus 2 sin square 2 theta. So we get a quadratic equation such that 2 sin square theta plus sin 2 theta minus 1 is equal to 0. So taking 2 sin 2 theta minus 1 common, this can be simplified into 2 sin 2 theta minus 1 and sin 2 theta plus 1. This is equal to 0. So either sin 2 theta minus 1 is equal to 0 or sin 2 theta plus 1 is equal to 0. That is sin 2 theta is equal to half or sin 2 theta is equal to minus 1. So for general value for 2 theta will be n pi minus 1 raised plus minus 1 raised to n pi by 6, because sin pi by 6 is half, or 2 theta is equal to 4 into n minus 1, because the value is minus 1. So 4 into n minus 1 into pi by 2. So theta will be substituting various values of n, we get values of theta as pi by 12 plus or minus 5 by 12, 5 pi by 12, or theta is equal to minus pi by 4. So here the terms which are common are minus pi by 4, 5 pi by 12 plus 5 pi by 12 and pi by 12. So number of values which are common for theta are minus pi by 4, 5 pi by 12 and pi by 12. So number of values are 3. So the answer is D 3. The number of solutions of the equation cos square x plus pi by 6 plus cos square x minus 2 cos x plus pi by 6 into cos of pi by 6 is equal to sin square pi by 6 in interval minus pi by 2 to pi by 2 is A0, B1, C2 or D3. First we consider the equation cos square x plus pi by 6 plus cos square x minus 2 cos x plus pi by 6 into cos of pi by 6 is equal to sin square pi by 6. We bring this term to LHS. So this gives us cos square x plus pi by 6 plus cos square x minus sin square pi by 6 minus 2 cos x plus pi by 6 into cos of pi by 6. This is equal to 0. So this is equal to x cos square x plus pi by 6 plus, now cos square x minus sin square pi minus pi by x can be written as, this can be written as cos of x plus pi by 6 into cos of x minus pi by 6, and the rest remains the same. So 2 cos x plus pi by 6 cos pi by 6 is equal to 0. Now we take cos of x plus pi by 6 common throughout the equation. So we get cos of x plus pi by 6 into cos of x plus pi by 6 plus cos x minus pi by 6 minus 2 cos pi by 6 is equal to 0. So simplifying it further, we get cos of x plus pi by 6 into 2 cos x, because this is in the form of cos A plus cos B. So 2 cos x into cos of pi by 6. This is the simplified form of this term, minus this, minus 2 cos pi by 6. This is equal to 0. So therefore cos of x plus pi by 6, now we take cos pi by 6 common, so cos pi by 6 and 2, we also take 2 common, so we are left with cos x minus 1. This is equal to 0. So cos pi by 6 cannot be 0 since it is a constant. So, and 2 is also a constant, so we are left with cos of x plus pi by 6 into cos of x minus 1 is equal to 0. Therefore cos of x plus pi by 6 is equal to 0, or cos x minus 1 is equal to 0. That is cos of x plus pi by 6 is equal to 0, or cos x equals 1. Now general equation for x plus pi by 6 can be given as x plus pi by 6 is equal to 2n plus 1 into pi by 2, and since the value of cos x is 1, general equation is given by x equals 2n pi. So therefore x plus pi by 6 is plus or minus pi by 2, since x lies between minus pi by 2 to pi by 2. The angle lies between pi by 2 and minus pi by 2, and x is 0. So simplifying it, we get this is plus or minus 2, so it can be either pi by 3 or minus 2 pi by 3 or x equals 0. So the possible values of x are 0, pi by 3. Since 2 pi by 3 lies outside minus pi by 2, 2 pi by 2, so this will be eliminated. So there are only two possible values of x, which are 0 and pi by 3. So the number of solutions are 2. So the answer is C, 2. Equation sin raised to 6x plus cos raised to 6x is equal to a square has real solution if a belongs to minus 1 to 1, b a belongs to the range minus 1 to half, c a belongs to the range minus half to half, d none of these. So first we consider this equation sin raised to 6x plus cos raised to 6x equals a square. This can be written as sin square x cube plus cos square x cube equals a square. So applying a cube plus b cube formula, we get sin square x plus cos square x into sin raised to 4x minus sin square x cos square x plus cos raised to 4x. This is equal to a square. Now sin square x plus cos square x is 1 into sin raised to 4x plus cos raised to 4x minus sin square x cos square x is equal to a square. This can be written as sin square x plus cos square x the whole square minus 2 sin square x cos square x minus sin square x cos square x is equal to a square. So this term is 1. So we are left with 1 minus 3 times sin square x cos square x is equal to a square. Now in this term we divide and multiply by 4. So we get 1 minus 3 by 4, 2 into sin x into cos x the whole square. This is a square. This term is sin 2x. So we get 1 minus 3 by 2 sin square 2x. This is equal to a square. That is, this is 3 by 4. So 3 by 4 sin square 2x equals a square minus 1. That is 3 by 4 sin square 2x is 1 minus a square. Therefore sin square 2x is 4 by 3 into 1 minus a square. Now the sin term lies between 0 to 1. It cannot exceed 1 and it cannot be less than 1. So RHS also lies within this range. So we can say 0 is less than equal to 4 by 3 1 minus a square, which is less than 1. That is 0 is less than 1 minus a square is less than equal to 3 by 4. So that is 1 minus a square is greater than equal to 0. So that is a square is less than equal to 1. Similarly, a square is less than equal to 1 minus 3 by 4 is less than equal to a square. That is, a square is greater than equal to 1 by 4. That is, a is less than equal to half, or a is less than equal to minus half. So a lies between minus 1 and 1. So combining these two relations, we can say a belongs to minus 1 to minus half union half to 1. So the answer is none of these, because there is no mentioning of this range. In triangle ABC, if b square plus c square is equal to 3a square, then cot b plus cot c minus cot a is equal to what? The options are 1, ab by 4 times ab upon 4 times area of triangle, c is 0, and or d, ac upon 4 times area of triangle. So we have to find cot b plus cot c minus cot a. We convert this into sine and cos. So we get cos b upon sine b plus cos c upon sine c minus cos a upon sine a. We cross multiply these terms, we get cos b sine c plus cos c sine b upon sine b sine c minus cos a upon sine a. This is the formula for sine of b plus c. So sine of b plus c upon sine b sine c minus cos a upon sine a. Again we cross multiply, we get sine a sine b plus c minus cos a sine b sine c divided by sine a sine b sine c. This can be written as a square minus bc cos a upon k times abc, where k is the constant of proportionality between the angles and the sides. So this is a square minus bc into cos a is using cosine rule, we get b square plus c square minus a square upon 2bc divided by abc into k, where k is sin a by a equals sin b by b equals sin c by c. So now we have cot b plus cot c minus cot a is equal to, simplifying this we get a square minus a square divided by abc into k, which is equal to 0. So the answer is C, 0. In triangle ABC, cot of a by 2 plus cot of b by 2 into a sin square b by 2 plus b sin square a by 2 is equal to, the options are cot c, c cot c by 2 and c cot c by 2. So let us consider this equation, this expression, cot a by 2 plus cot b by 2 into a sin square b by 2 plus b sin square a by 2. This can be written as c by 2. This is simplified into c by 2 cos c by 2 divided by sin a by 2 into sin b by 2. This term remains the same, a sin square b by 2 plus b sin square a by 2. So this is cos c by 2. We shift the denominator to this term, we get sin b by 2 into a divided by sin a by 2 plus b into sin a by 2 upon sin b by 2. Now by the property of triangle, we substitute the respective values of cos and sin. So we get root of, for cos c it is root of s into s minus c upon ab into a into sin b by 2 is root of s minus a into s minus c upon ac divided by root of sin a by 2 is s minus a s minus b s minus c upon bc plus b into root of, for sin a by 2 again sin s minus b into s minus c upon bc divided by root of, for sin b by 2 it is s minus a into s minus c upon ac. This can be simplified as s into s minus c upon ab into root of s minus a upon s minus b into ab plus root of s minus b upon s minus a into ab, that is root of s minus c into s minus a plus s minus b upon root of s minus a into s minus b. The denominator gets cancelled, so we have s minus c into s, this is 2s minus a minus b upon root of s minus a into s minus b. This is c into root of s into s minus c upon s minus a into s minus b, which is the formula for cot c by 2. So this is c into cot c by 2, which is option D. In triangle PQR, angle R is pi by 2 if tan of p by 2 and tan of q by 2 are roots of the equation ax square plus bx plus c equals 0, where a is not equal to 0, then a plus b equals c, b plus c equals a plus c equals b, or b equals c. So now we divide throughout by a. In this equation we get x square plus b by a x plus c by a. This is equal to 0. So tan p by 2 and tan q by 2 are roots of the equation. So we can say tan p by 2 plus tan q by 2 is minus b by, because the sum of the roots is the coefficient of x into minus 1, and similarly the product is c by a. So tan p by 2 into tan q by 2 is c by a. Let this be equation 1, let this be 2. We can write equation 1 in an alternative form such that tan alpha by 2 plus tan pi by 4 minus alpha by 2 is equal to minus b by. And similarly for equation 2 we can write tan alpha by 2 tan of pi by 4 minus alpha by 2. So now we can say tan alpha by 2 plus 1 minus tan alpha by 2 upon 1 plus tan alpha by 2 is equal to minus b by a. Expanding this tan of pi by 4 minus alpha by 2. So that is tan alpha by 2 into 1 plus tan alpha by 2 plus 1 minus tan alpha by 2 divided by 1 plus tan alpha by 2 is equal to minus b by a. So that is tan square alpha plus 1 alpha by tan square alpha by 2 plus 1 divided by 1 plus tan alpha by 2 is equal to minus b by a. Let this be equation 3. Similarly, we modify equation 2 such that tan alpha by 2 into 1 minus tan alpha by 2, we expand the term tan of pi by 4 minus alpha by 2 on 1 plus tan alpha by 2. This is equal to c by a. So we get tan of alpha by 2 minus tan square alpha by 2 upon 1 plus tan alpha by 2 is equal to c by a. This is equation 4. Now we add equation 3 and 4. We get 1 plus tan alpha by 2 upon 1 minus tan alpha by 2 is equal to minus b by a plus c by a. This is plus. Okay, so this term gets cancelled. So we have 1 is equal to minus b by a plus c by a. So that is minus b plus c is equal to a. Therefore c is equal to a plus b, which is option A. If in a triangle ABC, A is equal to 5, B is equal to 4, A is pi by 2 plus B, then angle C is, these are the options. So first we use sine rule. So sine rule says A upon sine A plus B upon sine B, A upon sine A is equivalent to B upon sine B. That is, A is 5. So 5 upon sine A is equal to 4 upon sine B. Now A is equal to pi by 2 plus B. So 5 upon sine pi by 2 plus B is equal to 4 upon sine B. That is, this can be written as cos B. So 5 upon cos B is equal to 4 upon sine B. Therefore, tan B is 4 by 5, equation 1. Now A is equal to pi by 2 plus B. So tan A is tan of pi by 2 plus B, which is minus cot B. So this is the reciprocal of tan B. So we get minus 5 by 4, which is tan A, equation 2. Now C is pi minus A plus B. Since sum of all angles of a triangle is 180 degree, that is pi radians. So tan C is equal to tan of pi minus in bracket A plus B. This is equivalent to minus tan of A plus B. We expand the terms, we get minus tan A plus tan B upon 1 minus tan A tan B. We substitute the values, we get minus of minus 5 by 4 plus 4 by 5 divided by 1 minus 5 by 4 into 4 by 5, and we finally get 9 by 40. So C is tan inverse of 2 into 1 by 9 upon 1 minus 1 by 9 the whole square. That is, C is equal to 2 tan inverse of 1 by 9, which is option D. If A, B, C, let A, B, C be positive real numbers and the value of theta equals tan inverse of root of A into A plus B plus C upon BC plus tan inverse of root of B into A plus B plus C upon CA, plus tan inverse of root of c into a plus b plus c upon ab. Then tan theta is equal to a0 b1 c a plus b plus c upon abc d ab plus bc plus c upon a plus b plus c. So tan theta is this. Let s square be a plus b plus c by abc. So we substitute in the equation of theta, we get theta is equal to tan inverse of root of a square s square plus tan inverse of root of b square s square plus tan inverse of root of c square s square. That is equal to tan inverse of as plus tan inverse of bs plus tan inverse of cs. This can be written as tan inverse of as plus bs plus cs minus abc s cube divided by 1 minus abs square minus ac s square minus bc s square. This is equal to theta. So tan theta is equal to s into, taking s common, we get s into a plus b plus c minus abc s square upon 1 minus ab, taking s square common in these three terms, we get ab plus bc plus ca into s square. Now this term can be written as s into a plus b plus c minus a plus b plus c divided by 1 minus ab plus bc plus ca into s square. So this term is 0, so hence the whole term becomes 0, so tan theta is 0. So the answer is a 0. If sine inverse of x plus sine inverse of y plus sine inverse of z is equal to pi by 2, then the value of x square plus y square plus z square plus 2xyz is equal to a0, b1, c2 or d3. First, put sine inverse x is equal to alpha and sine inverse y is equal to beta and sine inverse z is equal to gamma. So substituting it in this condition, we get alpha plus beta plus gamma is pi by 2. That is alpha plus beta is pi by 2 minus gamma. Therefore cos of alpha plus beta is cos of pi by 2 minus gamma. Applying cos of a plus b formula, we get cos of alpha cos beta minus sin alpha sin beta. Similarly, now cos of pi by 2 minus theta is sin theta. So we have sin gamma. We have sin alpha is equal to x. So therefore cos alpha is root of 1 minus sin square x, that is root of 1 minus x square. Similarly, cos beta is root of 1 minus y square. So substituting in this equation, we get root of 1 minus x square into root of 1 minus y square minus xy is equal to z, since sin alpha is z. That is root of 1 minus x square root of 1 minus y square is xy plus z. So squaring both sides, we get x square plus y square plus z square plus 2xyz is equal to 1. So the value of x square plus y square plus z square plus 2xyz is 1, that is B, B1. 4 tan inverse of 1 by 5 minus tan inverse of 1 by 70 plus tan inverse of 1 by 99 is option A pi by 2, option B pi by 3, option C pi by 4, option D pi by 6. So first we simplified this term. We have 4 tan inverse of 1 by 5 minus tan inverse of 1 by 70 plus tan inverse of 1 by 99. This can be written as 2 times 2 into tan inverse of 1 by 5 minus tan inverse of 1 by 70 plus tan inverse of 1 by 99. This can be expressed as tan inverse of 1 by 5 plus tan inverse of 1 by 5. So we simplify it and we get 2 times tan inverse of 2 by 5 upon 1 minus 1 by 25, that is equal to tan inverse of 1 by 70 plus tan inverse of 1 by 99. Again we apply the same formula. We get tan inverse of 2 tan inverse of 5 by 12 is equal minus tan inverse 1 by 70 plus tan inverse 1 by 99, that is tan inverse of 2 into 5 by 12 upon 1 minus 5 by 12 the whole square minus tan inverse of 1 by 70 plus tan inverse of 1 by 99. This is tan inverse of 120 by 119, and we solve this simultaneously. So we get tan inverse of 1 by 99 minus 1 by 70 upon 1 plus 1 by 99 into 1 by 70. So this is tan inverse of 120 upon 119 plus tan inverse of minus 29 upon 6931. That is tan inverse of 120 by 119 minus tan inverse of 693. This is minus, so we take this outside. So we get tan inverse of 29 upon 6931. Again we apply the formula. Tan inverse of 120 by 119 minus 1 upon 239. This is 1 upon 239 divided by 1 plus 120 upon 119 into 1 upon 239. So this turns out to be tan inverse of 1, which is pi by 4. So the answer is C, pi by 4. If sine inverse of A plus sine inverse of B plus sine inverse of C is pi, then the value of A root of 1 minus A square plus B root of 1 minus B square plus C root of 1 minus C square will be option A 2ABC, B 2 B ABC, C half ABC, D 1 by 3 ABC. So let sine inverse of A be capital A, sine inverse of B be capital B, and sine inverse of C be capital C. So sine A is small a, sine B is small b, and sine C is small c. And A plus B plus C is pi, that is property of a triangle. Then sine 2A plus sine 2B plus sine 2C is equal to 4 times sine A sine B into sine C. Let this be equation 1. Now sine A cos A plus sin B cos B plus sin C cos C is equal to 2 sin A sin B to sin C. So this term can be written as sin of A. Cos A is root of 1 minus sin square A. So root of 1 minus sin square A. Similarly, sin B into root of 1 minus sin square B plus sin C into root of 1 minus sin square C. This is equal to 2 sin A sin B into sin C. Now by sine rule we can substitute these values with the values of the sides, that is A into root of 1 minus A square plus B into root of 1 minus B square plus C into root of 1 minus C square is equal to 2 times ABC by use of sine rule. Now sine inverse A plus sine inverse B plus sine inverse C is pi. So the answer is 2ABC is equal to A into root of 1 minus A square plus B into root of 1 minus B square plus C into root of 1 minus C square, which is option A. If cos inverse of root P plus cos inverse of root of 1 minus P plus cos inverse of root of 1 minus Q is 3 pi by 4, then the value of Q is A1, B1 by root 2, C1 by 3, D1 by 2. So first let alpha be cos inverse of root P, beta be cos inverse of root of 1 minus P, and gamma be cos inverse root of 1 minus Q. So cos alpha is root P, cos beta is root of 1 minus P, and cos gamma is root of 1 minus Q. Therefore sin alpha is root of 1 minus cos square x, cos square alpha, that is 1 minus P. Similarly sin beta is root of 1 minus cos square beta, that is root P, and sin gamma is root Q. So this equation can be written as cos inverse of root P is alpha plus beta plus gamma is 3 pi by 4, that is alpha plus beta is equal to 3 pi by 4 minus gamma. We take cosine on both sides, we get cos alpha plus beta is equal to cos 3 pi by 4 minus gamma. We expand this using cos of A plus B formula. We get cos alpha cos beta minus sin alpha sin beta, and this is minus cos of pi by 4 plus gamma. So we substitute the corresponding values which we got from this. We have root of P into root of 1 minus P minus root of 1 minus P into root of P is equal to minus 1 by root 2 root of 1 minus Q minus 1 by root 2 root Q. We expand this using cos of A plus B formula. So simplifying it, we get root of 1 minus Q is equal to 0. 1 minus q minus root q is equal to 0. That is root of 1 minus q is equal to root q. Squaring both sides, we get 1 minus q is q. That is 1 is equal to 2q. That is q is equal to half, which is option D. 4 tan inverse of 1 by 5 minus tan inverse of 1 by 239 is equal to a pi, b pi by 2, c pi by 3 and d pi by 4. Now we simplify each and every term. That is, we simplify 4 tan inverse of 1 by 5 first. So we know that 2 tan inverse of x is tan inverse of 2x upon 1 minus x square. So we apply this formula for this 4 tan inverse of 1 by 5. We can write this as 2 into 2 tan inverse of 1 by 5. That is 2 tan inverse of 2 by 5 upon 1 minus 1 by 5 square. That is, this is first term. So 2 tan inverse of 10 by 24. Again applying the formula, we get tan inverse of 2 into 10 by 24 upon 1 minus 10 by 24 the whole square. We get 4 tan inverse of 1 by 5 is equal to tan inverse of 120 by 119. Now for tan inverse of 1 by, so now we substitute this value in the given expression. We get tan inverse of 120 by 119 minus tan inverse of 1 by 239. This is equal to tan inverse of 120 divided by 119 minus 1 by 239 divided by 1 minus the product, that is 120 upon 119 into 1 upon 239. This can be simplified and we finally get tan inverse of 120 into 239 minus 1 upon 119 into 239 minus 120. This is plus here. So this turns out to be tan inverse of 1, that is pi by 4. So the answer is D, pi by 4. Cot inverse of root of 1 plus sin x plus root of 1 plus sin x upon root of 1 minus sin x minus root of 1 plus sin x. This is equal to, these are the options, pi minus x, 2 pi minus x, x by 2 and pi minus x by 2. So in this term we multiply and divide this expression with its conjugate. So this is cot inverse of root of 1 plus sin x plus root of 1 plus sin x upon root of 1 minus sin x minus root of 1 plus sin x. So the conjugate of the denominator is root of 1 plus sin x plus root of 1 plus sin x upon root of 1 plus sin x plus root of 1 plus sin x. This is in the form of a plus b, a minus b, and this form a plus b the whole square. So we get cot inverse of root of 1 plus sin x plus root of 1 plus sin x root of 1 minus sin x, there's a correction, 1 minus sin x so the whole square divided by root of 1 minus sin x the whole square minus root of 1 plus sin x to whole square. So this is cot inverse of one minus sin x plus 1 plus sin x plus 2 root 1 minus sin square x, since the product is in the form of a plus b and a minus b, and here we get 1 minus sin x minus 1 minus sin x. This is equal to cot inverse of two into 1 plus cos x, root of 1 minus sin square x is cos x, divided by minus 2 sin x. We convert it into half angle form. We get cot inverse of two cos square x by 2 upon sin x is 2 sin x cos x. So 2 sin x by 2 cos x by 2. Cos gets cancelled, 2 gets cancelled. We are left with cot inverse of minus cot x by 2, which is cos upon sin. So this is equal to cot inverse of cot of pi minus x by 2. So this is equal to pi minus x by 2, which is option D. If angle A is 90 degree in the triangle ABC, then tan inverse of C by A plus B plus tan inverse of B by A plus C is 0, 1, pi by 4 or pi by 6. So first we draw a right angle triangle. This is 90 degree. This is A, B and C. So if AC is B, AB, C, then the hypotenuse is root of B square plus C square, which is A. So A square is B square plus C square. Now tan inverse of C by A plus B plus tan inverse of B by A plus C. This is equal to, we apply tan inverse of A plus tan inverse of B formula. So we get tan inverse of C by A plus B by A plus C upon 1 minus C by A plus B into B upon A plus C. This is equal to tan inverse of CA plus C square plus AB plus B square divided by A square plus AB plus CA plus BC minus BC. So this can be simplified as tan inverse of, now B square plus C square is A square. So we substitute this, we get A square plus AB plus CA upon A square plus AB plus CA. That is equal to tan inverse of 1, which is pi by 4, which is option C. It is given that x lies between 0 and 1 by 2. Then the value of tan of sine inverse of x by root 2 plus root of 1 minus x square by root 2 minus sine inverse of x is a 1, b root 3, c minus 1, d 1 by root 3. So first let sine inverse of x be theta. So therefore sine theta is x. Now we rewrite the equation, the expression tan of sine inverse of, since they have the same denominator, we can write this x plus root of 1 minus x square upon root 2 minus sine inverse of x. So we substitute the value, we get tan of sine inverse sine theta plus root of 1 minus sine square theta is cos theta. So sine theta plus cos theta divided by root 2 minus sine inverse of sine theta. So this is equal to this term can be written as tan of sine inverse of sine theta plus pi by 4, since sine and cos pi by 4 are 1 by root 2. So sine inverse of sine theta is theta. So this gives us tan of sine inverse of sine theta plus pi by 4 is theta plus pi by 4 minus theta. So this is tan of pi by 4, which is 1. So the answer is option A, 1. If tan inverse of 2x plus tan inverse of 3x is pi by 4, then the value of x is minus 1, 1 by 6, minus 1 comma 1 by 6 or 2 by 3. So first we rewrite the equation. Tan inverse of 2x plus tan inverse of 3x is equal to pi by 4. We apply the formula tan inverse of A plus tan inverse of B. We get tan inverse of 2x plus 3x upon 1 minus 2x into 3x. This is equal to pi by 4. Simplifying it, we get 5x upon 1 minus 6x square. This is equal to pi by 4 is tan inverse of 1. So hence we can say 5x upon 1 minus 6x square is 1. That is 5x is 1 minus 6x square. So therefore 6x square minus plus 5x minus 1 is 0. We can factorize it in this way: x plus 1 into x minus 1 by 6 is equal to 0, where x plus 1 can be 0 or x minus 1 by 6 is 0. So that is x equals minus 1 or x equals 1 by 6, which is option C.
If u is equal to log tan pi by 4 plus x by 2, then cos hyperbolic u is equal to, and the options are A sec x, B cosec x, C tan x, and D sin x. To solve it, we shift log to the left hand side. Therefore we get e raised to u is equal to 1 plus tan x upon 1 minus tan x by 2. This substitution happens when we apply the formula of tan A plus B. Using the formula of cos hyperbolic u, which is equal to e raised to u plus e raised to minus u upon 2, which gives us e raised to 2u plus 1 upon 2 e raised to u. Substituting the value of e raised to u we have just received here by solving, we substitute and get 1 plus tan x by 2 upon 1 minus tan x by 2 the whole square plus 1 upon 2 into 1 plus tan x by 2 upon 1 minus tan x by 2. Solving it further, we would get 2 of 1 plus tan square x by 2 upon 2 of 1 minus tan x by 2 into 1 plus tan x by 2. Solving this equation, we would get 1 plus tan square x by 2 upon 1 minus tan square x by 2. If we solve this further, taking the numerator down, we would get 1 minus tan square x by 2 upon 1 plus tan square x by 2. This is the formula for 1 upon cos x. The inverse of cos x, as we know, is nothing but sec x, which is option A. If cos hyperbolic alpha is equal to sec hyperbolic alpha, then tan square of x by 2 is equal to, options are cos square alpha by 2, sin square alpha by 2, cot square alpha by 2, or tan hyperbolic alpha square by 2. First, we write cos hyperbolic alpha, which as we know is sec x, which gives us 1 upon cos x. Substituting the formula for 1 upon cos x, which is 1 upon 1 minus tan square x by 2 upon 1 plus tan square x by 2, which gives us cos hyperbolic alpha upon 1, which is equal to 1 plus tan square x by 2 upon 1 minus tan square x by 2. Using componendo dividendo, we now get cos hyperbolic alpha minus 1 upon cos hyperbolic alpha plus 1, which gives us 2 tan square x by 2 upon 2, which is nothing but tan square x by 2. Solving this further, on the left hand side we would get 2 sin square hyperbolic alpha by 2 upon 2 cos square hyperbolic alpha by 2, which is equal to tan square x by 2. Solving this further, we get tan square alpha by 2, which is equal to tan square x by 2, which is option D. If cos of u plus iv is equal to x plus iy, then x square plus y square is equal to 1 is equal to cos square u plus sin hyperbolic square v. Option B, sin square u plus cos hyperbolic square v, cos square u plus cos hyperbolic square v, or sin square u plus sin hyperbolic square v. Expanding this equation, we get cos u cos iv minus sin u sin iv. We get this using the formula of cos a plus b. Solving these two terms, we would get cos u into cos hyperbolic b minus I sin u into sin hyperbolic v, which is equal to x plus iy. Now comparing these two terms, we would get x is equal to cos u into cos hyperbolic v, and y is equal to minus of sin u sin hyperbolic v. Squaring x and y and adding them, we would get x square plus y square is equal to cos square u into cos hyperbolic square v plus sin square u into sin hyperbolic square v. Substituting cos square u and sin square we would get 1 minus sin square u into cos hyperbolic square v plus sin square u into cos hyperbolic square v minus 1. Solving this equation, we would get cos hyperbolic square v minus sin square u. Adding 1 to both the sides, we would get x square plus y square plus 1 is equal to cos of hyperbolic square v plus 1 minus sin square u. If we solve this further, we would get cos of hyperbolic square v plus cos square u, which is nothing but option C. Find imaginary part of sine inverse of cosec theta. Options are log cot theta by 2, option B pi by 2, option C 1 by 2 log of cot theta by 2, and option D none of these. Since we have sine inverse of cosec theta, we would solve it as cosec theta is equal to sine of x plus iy, where x is the real part and y is the imaginary part. Which is equal to sin x cos of hyperbolic y plus I cos x sin hyperbolic y, which we get by expanding using the formula sin a plus b. Now comparing the real and imaginary parts from the above equation, we get cos x sin hyperbolic y is equal to 0. Therefore, we know that cos x would be 0, giving us x as pi by 2. Substituting x for sine, we get sine of pi by 2 cos hyperbolic y is equal to cosec theta. Or we could say y is equal to cos hyperbolic inverse of cosec theta. Therefore, y is equal to log of cosec theta plus cot theta, which would give us log of cot theta by 2, which is nothing but option A. If cos hyperbolic z is equal to sec theta, then sin hyperbolic z equals option A cosec theta, option B cot theta, option C tan theta by 2, or option D tan theta. We know that cos hyperbolic square z minus sin hyperbolic square z equals 1. Therefore, sin square hyperbolic z is equal to cos hyperbolic square z minus 1, giving us sin hyperbolic square z is equal to sec square theta minus 1, which gives us tan square theta. Taking root on both the sides, sine hyperbolic z would give us tan theta, which is option D. If cosec theta is cot hyperbolic x, then the value of tan theta is option A cos hyperbolic x, option B sin hyperbolic x, option C tan hyperbolic x, or option D cosec hyperbolic x. Expanding cosec theta, we get 1 plus cot square theta is equal to cot hyperbolic square x. Cot square theta is equal to cot hyperbolic square x minus 1, which is nothing but cosec of hyperbolic square x. Therefore, cot square theta would give us cosec hyperbolic square x. Taking root on both the sides, we get cot theta is equal to cosec hyperbolic x. Taking inverse of both, we get tan theta is equal to sin hyperbolic x, which is nothing but option B. If sin x into cos hyperbolic y is equal to cos theta and cos x sin hyperbolic y is equal to sin theta, then sin hyperbolic square y equals option A sin square x, option B cos hyperbolic square x, option C cos square x, or option D 1. We square and add the given terms, which gives us sin square x into cos hyperbolic square y plus cos square x into sin hyperbolic y equals 1. Substituting the formulas for cos hyperbolic square y and sin hyperbolic square y, we get sin square of x into 1 plus sin hyperbolic square y plus cos square x into sin hyperbolic square y is equals 1. Therefore, sin hyperbolic square y is equals 1 minus sin square x, which is cos square x, which is option C. Tan hyperbolic pi I by 4 minus cot hyperbolic pi I by 4 is equal to option A 0, option B 2, option C root 2, or option D none of these. Solving for tan hyperbolic pi I by 4 gives us I, and solving for minus cot hyperbolic pi I by 4 gives us minus of minus I, which gives us I plus I, which is equal to 2I. Since it's none of these, it's option D. The imaginary part of sin square x plus iy is option A 1 by 2 cos hyperbolic 2x cos 2y, option B 1 by 2 cos 2x cos hyperbolic 2y, option C 1 by 2 sin hyperbolic 2x sin 2y, or option D 1 by 2 sin 2x sin hyperbolic 2y. To solve this, we write sin square 2 into x plus iy, which would give us 1 minus cos 2 x plus iy. Solving the right side part, we would get 1 minus cos of 2x cos 2iy minus the bracket sin 2x sin 2iy, which is equal to 1 minus cos 2x cos hyperbolic 2y plus I sin 2x into sin hyperbolic 2y. Therefore, the imaginary part of sin square x plus iy is 1 by 2 sin 2x sin hyperbolic 2y, which is option D. The value of 2 cot hyperbolic inverse z by 2 is log z minus 2 upon z plus 2. Option B 1 by 2 log z minus 1 upon z plus 1. C 1 by 2 log z plus 1 upon z minus 1, and option D minus log z minus 2 upon z plus 2. We know that 2 cot hyperbolic inverse z by 2 equals log of x plus 1 upon x minus 1. Substituting this formula, we get 2 cot hyperbolic inverse z by 2 equals log of z by 2 plus 1 upon z by 2 minus 1. Which gives us log of z plus 2 upon z minus 2. If we solve this further, we would get minus of log z minus 2 upon z plus 2, which is option D. Sec hyperbolic inverse of sin x equals log of cot x by 2, option B log tan x by 2, option C log cot x, or option D none of these. We know sec hyperbolic inverse of sin x is equals log of 1 plus root of 1 minus sin x the whole square upon sin x, which gives us log of 1 plus cos x upon sin x. Solving this further, we get log of 2 cos square x by 2 upon 2 sin x by 2 cos x by 2, which is nothing but log of cot x by 2, option A. If cosec hyperbolic inverse of 1 is equal to x plus iy, then the value of y is 1, 0, log of 1 plus root 2, or D minus 1. We know cosec hyperbolic inverse of x is equal to log of 1 plus root of 1 plus x square upon x, but cosec hyperbolic inverse of 1 is equal to log 1 plus root 2 upon 1. We get this by substituting the value of x as 1. Therefore, x plus iy as cosec hyperbolic inverse of 1 is x plus iy equals log of root 2 plus 1. On comparing, y is equal to 0, which is option B. The value of tan inverse of 2 raised to minus 1 is log 2, option B, log 2 raised to minus 1, option C, log root 3, or option D, none of these. We know that tan hyperbolic inverse of x is equal to 1 by 2 log of 1 plus x upon 1 minus x. Therefore, tan hyperbolic inverse of 1 by 2 would be 1 by 2 log of 1 plus 1 by 2 upon 1 minus 1 by 2, which would be 1 by 2 log of 3 by 2 upon 1 by 2, which is 1 by 2 log of 3. Taking 1 by 2 as an exponent, we get log of 3 raised to 1 by 2, which is nothing but log of root 3, which is option C. The imaginary part of tan inverse of cos theta plus I sin theta is option A, tan hyperbolic inverse of sin theta, option B, tan hyperbolic inverse of infinity, option C, 1 by 2 tan hyperbolic inverse of sin theta, or option D, none of these. We know that tan inverse of cos theta plus I sin theta is equal to pi by 4 plus I by 4 log of 1 plus sin theta upon 1 minus sin theta, where cos theta is greater than 0. Then the imaginary part of tan inverse of cos theta plus I sin theta would be 1 by 2 tan hyperbolic inverse of sin theta, as tan hyperbolic inverse of x is 1 by 2 log of 1 plus x upon 1 minus x, which is option C.